Okay, guys, with today's lesson, 1.3, we're talking about things that we can identify from a graph. What I am focusing mainly on today is domain and range, and then intervals of increase, decrease, and constant. Increase means where the graph goes up, decrease means where it goes down, and constant where it stays the same. And then at the end, we're going to talk about piecewise functions. There's going to be some things that I skip just because we will pick them up in the next chapter. So I don't want to waste too much time on that now. But when I talk about domain and range, what does that mean? Tell me.
Domain is like the distance xy.
Perfect. Perfect. Domain, x values. Range, y values. Yes? Everybody with me? Okay. When we talk about domain, there's some very specific things in today's lesson that you have to do in order to write your domain and range and intervals of increase, decrease, constant correctly. Domain is read from left to right, exactly how you read a book. You always start on the furthest left part of the graph to the furthest right that the graph goes. Domain is always left to right. Range is always from bottom to top. Some people say from low to high, all right? And that's very important because if I tell you that the domain is from -4 to 3, and you tell me it's from 3 to -4, those are two different intervals. You have to go from left to right. Everybody with me? All right, look at these dots on this graph, this example that they gave us. What do you notice about the dot here at 2, 4 and the dot here at 4, 0? One is open and one is closed. Is there a difference, or do they just, feel like making one dot closed and one dot open? There is a difference. Anybody remember what it is? Go ahead, you can tell me. Perfect. Good, good, good. The closed dot means the value is included. This would be our greater than or equal to or less than or equal to. That means whatever value is right there, it is included. If you have an open dot, it's not included. That makes a big difference because we are going to write our domain and range, increase, decrease, and constant, in what's called interval notation. How many of you have heard that before? Interval notation, good. There's two different kinds of interval notation. You can have a bracket or a parenthesis. If a value is included, if it's greater than or less than or equal to, if there is a closed dot, we use brackets because the value is included. Brackets mean the value is included. If it's a parenthesis, it means the value is not included. All right, that's important. Now, another thing, what do you notice about the ends of this graph? My parabola-ish looking thing. What do you notice here and here? Go ahead, tell me.
That there's no arrows.
There's no arrows. What do arrows at the end of graphs mean? They go on forever and ever and ever and ever and ever. So let's think about that for a second. If there were arrows, we're going to talk about that in a second. Over here on the left-hand side, this is negative infinity on the x-axis, and this is positive infinity on the y-axis, on the x-axis. On your y, the negative infinity is down here, and the positive infinity is up here, okay? Lots of times we like to read domain and range where graphs have specific starting and stopping points. Now, there's a bunch of different ways you guys can do this. Some of us are a little more visual than others. But if I asked you guys to tell me the domain of this graph, you would tell me from left to right, what is the furthest left on the x-axis that this graph uses for values? -1. Is -1 included or not? How do you know that? Because it's closed. So -1. 2, what's the furthest right that this graph goes? 4 on the x-axis, correct? Is it included or not?
No.
How do you know? Perfect. Good job. So now if I'm going to state the range is from where to where? Do I start at the top? No, we start where? At the bottom. We read the range on the y-axis. So what's the furthest down that this graph goes? -5. Is it included? It sure is. And it goes all the way up to what?
4.
To 4. Good. Does it include it or not? Okay, I have another question for you. Just say, hypothetically speaking, that black dot wasn't there. It was just this graph. Would this value still be included? Yes, because it's part of the graph. If it wasn't, there would be like a hole. It would go like this, and this would be white in here. So you would see a specific, but just if the graph doesn't have a specific point at the top, but there is a continuous piece of the graph, then that is included in that area. Does that make sense? All right, if I said to you, like this question says, what is the value f negative 1? Well, you're sitting here being like, what? What that question is asking is at where x is negative 1, what is the value of y? Where x is negative 1, what is the value of y? What is the value right here? 0. Good. Right here, f of 2. That means, well, on the x-axis, at 2, what is the value of y? 4. That's all that question's asking. They're just saying, hey, at this point on the x-axis, what is the y value? Questions. All right, let's look at something like this. Look at 7 and 9. How are 7 and 9 different?
7 has arrows.
7 has arrows, and 9 does not. That means we're going to have infinities on this. So if I asked you guys, and you're going to have a question like this on your quiz, you might have a graph that's all pieces, where there's gaps, holes, something like that. You'll have a practice on that. But what is the domain? Negative infinity, positive infinity here. How many of you agree? I agree. How come? This arrow means this is going to continue for what? Ever. It's going to continually get wider, guys. So we would say negative infinity to positive infinity. Why didn't I use brackets? Is there a stopping point? Can you guys tell me, oh, this is where infinity stops? No. Always, always, always we have parentheses on infinities because there is no specific stopping point. Now, when I talk about range, this is where this gets a little hairy. When I talk about range, remember, tell me again, how do I read range? From where to where? Bottom to top. So think about it. This is negative infinity down here, right? Because this graph is still down here. So your range is from negative infinity to where? To positive 1. Is positive 1 included? Yes. Okay. Now some people are like, but I don't see a dot. You do see a dot because there is that is closed right there. Right? So it's to 1, and then you have your lovely bracket. We good? Okay. Yes, sir.
So if the circle is open, you'll clearly see that it's open.
Correct. You will clearly see it. Like just say we have this. It's two pieces of a graph, yeah? So you would have a domain. It would be negative infinity to what on the x-axis? On the x-axis. Negative 1. Then there'd be a gap. You'd have a union, and it would start again where? 1, 2, infinity, okay? We're going to have some stuff like that. Not just yet, but on your homework probably tonight. And again, we'll go over it tomorrow, I promise. All right, when we have something like this, we like this. These are easy. Why is this one easier? It has a specific starting and stopping point. It's real easy to see. So my domain from left to right. What's the furthest left that this graph goes? Negative 4, included or not? Yep. All the way to what? Positive 4. Perfect. Easy. Range, bottom to top. What's the lowest value? 0 to what? 1, 2, 3. Yep. And what's on either end? Y brackets. Because all of it's included. Good. Good, good, good. Yep.
What if it was, for example, to the left side, right?
Mm-hmm.
It was not included. Would it still be a 0? Like, would it have a bracket with a 0 or no?
Like here?
Yeah.
So, good question. If it looked like this, guys, your domain would be parenthesis negative 4 to 4, right? And then, very good question, because Jean said, will it still be included? Is it included on this left-hand side of the graph, on y? No, but is it included here? Then yes, you could include it. If it's included in one spot, you kind of can think of it as the closed dot supersedes the open dot. Good question. All right, how are we? Do I have anything else in this slide? All right, this is what I was talking about. We're going to come back to this in chapter 2. This is algebraically figuring out domain and range. It's where you'd have to say, okay, well, what can I put in? What do we know about square roots and getting real answers? You can't take the what? Square root of a negative. So in this case, we'd have to figure out what would make the expression negative, and then you'd have exclusions and stuff like that. But again, algebraically, we're going to get back to that in chapter 2. So we'll come back. We will come back. How many of you remember, you don't have to tell me, yes, I know exactly how to do it, but you've heard about the vertical line test. Okay, we're probably not going to have a bunch of these on your quiz because these are easy. But the vertical line test is exactly what it sounds like. If you have a picture, if you have a graph, a picture of a graph in front of you, and you literally draw a vertical line anywhere on the graph. So here we go. Here's a picture right here. And I draw a vertical line right here. How many times does that vertical line touch your graph? Twice. If it touches your graph more than once, this is not a function. So using the vertical line test to tell if a graph is a function or not, you draw a vertical line anywhere. If anywhere on the graph you can draw a vertical line and it touches the function more than once, it's not a function. So look, I draw a vertical line here. How many times does it touch? Once. What about if I draw it here? Oh, still just once. What about if I draw it here? Still just once. So this would be yes, this is a function. And that goes back with algebraically when you think about it. Algebraically, when you think about it, if you list out a set of points, what cannot repeat? What values can't repeat? Anybody remember? X. X values cannot repeat. Good. All right, so real quick. Function, yes or no on A? Yes. Why? Because the vertical line. Good. Okay. What about B? Okay. Perfect. Good. All right. That's a simple little. We like that. All right. Now, guys, everything I tell you in this is super duper important. All right. The reason that I'm going through this a little slower is because this can be really tricky. This is a very easy concept, but it can be tricky. We're talking about intervals of increase and decrease. I want you to write real big somewhere. Remind yourself 100 times. Star it, circle it. You read increase, decrease, and constant. Whoops. On the x-axis. Notice how big I wrote that. It's very important. The y-axis has nothing to do with your increase and decrease because you're not talking about how much it went up or down. You're talking about the interval over which the increase or decrease happened. The reason why this is confusing is because when I say increase and decrease, what are the two directions you think of? Up and down. What axis goes up and down? The y. Do we read intervals of increase, decrease, and constant on the y? No, that's why this is confusing. So what I'm saying to you right now is written right here in math language. I'm going to say it to you in layman's terms, teenage talk. All right? Increase means the graph is doing what? Going up. Decrease means it's going down. Constant means it's staying the same. When you're looking at a graph and you're analyzing it, do you have to have one of each? No, you might have a graph that just is continuous the whole time, constantly going up. You might have a graph that does all these funny things, but there's never any period of constant. That's fine. When you're asked to state increase, decrease, or constant, if there isn't any, you need to write the word none. Don't just leave it blank, because then I think you don't know. Don't write 0, because that's not it. All right, another thing that's super duper important, I want you to write down star, is parentheses. You only use parentheses when you're writing increase, decrease, and constant. And the reason why, you cannot increase and decrease simultaneously. There has to be a turning point from which your graph stops decreasing and starts increasing, or stops decreasing and becomes constant. You can't, at that specific point in time, you can't do both things at the exact same time. So that's why we don't use brackets. Some of you are like, I don't care why we don't use brackets. I just have to remember that. That's fine. I'm just telling you why. So here is my suggestion of what to do. Okay, I get to a question. I have this funny looking graph, and it says, state the domain or the domain and range. Okay, fine. And then the intervals of increase, decrease, constant. You're going to have a question like this on your quiz. So if I asked you what the domain was, what would you all tell me the domain is here? Negative 2 to 4. And what are my notations at the end? Perfect. Why? Because they're closed dots. Good. What would my range be? What's the furthest down it goes? 1. What's the furthest up it goes? 1 to 4. Perfect. What's on the ends? Okay, perfect. Now again, you might have gaps, you might have holes, that's okay. But when we talk about increase, decrease, and constant, my suggestion to you is to cross off the y-axis. Remind yourself that it does not matter. Now you don't even see those numbers, so you're not looking at how far up and down. Intervals of increase, decrease, and constant. I don't want to know how much it went up or how much it went down. I want to know the intervals on the x-axis over which this happened. So think about this. We always read from which way? Left to right. So I'm going to start over here on the left side of the graph. Guys, there is no shame in putting your pencil down, following the line. Who cares? No one is looking at you being like, oh, I can't believe Gene just had to trace it. If he gets it right, what does it matter, right? So follow the line. Ready? I'm going from here. And then I stop decreasing, correct? So my decrease is over the interval of what to what? Negative 2 to where? 0. Remember, we parentheses, but it's on the x-axis. So now I look at this and I go, okay, well, from here to here, what am I doing? It's staying constant. So this is constant from where on the x-axis to where on the x-axis? 0 to 2. Good. And then I follow my line again, and I'm here, and I go, whoop, what's it doing? It's going up. That's an increase from where on the x-axis to where on the x-axis? 2 to 4. Perfect. Now, I'll tell you right now, if you guys did not cross off the y-axis, some of you would tell me, oh, it went from 4 to 1 when it decreased. I agree with you. The y value went from 4 to 1, but that's not how we read intervals of increase, decrease, constant. It's only on the x. That makes sense? Mm-hmm. We're going to practice this a bunch, I promise. 2, with my fancy handwriting. Just kidding. All right, now these graphs are not the easiest to read. I know that, so I'm going to make a little notation here. Now, this looks like it flatlined, right? It didn't, so pretend it doesn't. So you guys are looking at this and you're like, wait, what? Okay, first of all, if I'm reading increase, decrease, constant, what am I crossing off? The y. I don't even want to look at it. I want to get myself confused. Because you guys can tell me, oh, from negative 2 to 2. No. I put arrows on the end of this, so what does that mean? Infinity. What's the domain and range for this function? Negative infinity, positive infinity. Okay, so look, I'm going to just put my pencil down, and I'm going to say, okay, on the left-hand side, the graph starts down here, and it's doing what the whole time? Increasing. So you guys would tell me that this was an increase from where to where? Negative infinity to? Positive infinity. Good. So now there's a line that says, well, what was the decrease, and what was the constant? Do you guys just leave it blank? No. What do we say? None. Nada. Nope. Non-existent. Don't tell me 0 because that's an actual numerical value, but tell me something that says, hey, there is none. There's no increase. There's no decrease, no constant, anything like that. Make sense? Okay, so here we got a picture here. I'm going to put dots here. So this is 1. We'll say this is 2. 3, -1, -2, -3. On your quiz, it won't be from a calculator. It will be an actual graph that you will see specific points. But I want the intervals of increase, decrease, constant. So they gave me some ordered pairs here and stuff. What am I going to do with the y value of my ordered pair? I'm going to cross it off. I don't even want to see it. It's going to confuse me. I don't care about it. The only thing I care about is the x-axis. So if I start right here, at whatever this point is, and I follow my red line, what's going on in my graph? It's increasing from where on the x-axis? -2. To where on the x-axis? -1. And what goes on the ends of those? Parentheses. Fantastic. So now this changes direction. It goes which way? Down. It goes down. How do we say down? Decrease. From where on the x-axis? -1 to where on the x-axis? +1. Very good. What goes on either end? Parentheses. All right, so now it stays constant, right? It just goes constantly up. Is that a thing? No, what's happening again? Oh, it's increasing again. We have another interval of increase. No big deal. From where to where is this increasing? From 1 to 2. So you can say union if you want to. You can say and, whatever. Is there an interval of constant on this graph?
No.
Nope. You can write nope. You guys with me?
Yeah.
I promise you, if you cross off the y values and then just say to yourself, from where on the x-axis to where, just keep reminding yourself it's not that bad. It's not that serious, right? Nah, I won't do that to you. We'll just do this. Okay, I got a nice little picture again. Say this is -2. Say this is 4, okay? So this is 1, 2, 3. I have ordered pairs that I see. What should I do? Let's just get rid of it. You can get rid of the whole thing if you want to, but yes, for sure, get rid of the y. This is -1 here. So let's start on the left-hand side. We always go left to right. What is the domain for this function? Left to right. What's the furthest left? -2. Include or not?
Yeah.
Yep. -2 to all the way over to 4. Good. Left to right. Draw your arrows if you need to. From here to there. Now my range is the lowest that it goes. What's the lowest it goes? -1 to what? To +1. Okay. Includes both. So starting on the left-hand side, I go what direction? I'm increasing. So we're increasing from where on the x-axis to where on the x-axis? -2 to 0. Perfect. And what goes on the ends of increase, decrease, constant? Parentheses. All right. Then from here to here, I'm just hanging out, staying straight. So from where to where are we constant? 0 to 2. Sounds good, guys. And then from where to where are we going down? From 2 to? Perfect. We're decreasing. Now again, you might have 2 intervals of increase, 2 intervals of decrease. You might have 2 intervals that are constant. It doesn't matter. Just put them in the right spot. How do we feel? Okay? All right. Okay, this part's super easy. We're just going to touch on this. This is if you could see this on a graph, like maybe in the essay or something, but a lot of times this works with, whoa, what happened? Okay, we're back. Okay, a lot of times this works with calculator stuff. Right, what does the word maximum mean? The maximum amount of money you're allowed to spend on your prom dress is the most. Do you ever get a minimum? Does your mom ever say, okay, the least amount you're allowed to spend? No, right? Well, there's never a minimum. But maximum is the highest or the most. Minimum is the lowest. Sometimes you'll have a graph that have a bunch of bumps, maximums, and a bunch of valleys, which are minimums. So when they talk about relative maxima and relative minima, the peaks are referred to as relative maximas. Inside your graph, these are all the high points. You see this a lot in like an EKG of the heart. You have the peaks, and then the valleys would be the relative minima. You could have more than one in a graph. So if there's an absolute max, that's the absolute highest the graph goes versus an absolute minimum. But if you just have relatives, they're saying, okay, the relative maximas are all the peaks of the hills, and the relative minimas, I guess you could say, are all the valleys, the low parts. Yes, you guys agree with me? Do you see that on here? Okay, that's all we need to touch on. All right, last thing we're going to talk about is piecewise. How many of you have seen a piecewise graph before? If you were in Algebra 2 Honors, you should have seen these before. Piecewise. When you graph, this is a piecewise function. Guys, what piecewise means is I want a piece of this and I want a piece of that. All right, you're going to graph lines. We should all know how to do that. We're going to graph maybe a parabola here or there. If you guys don't know, a parabola makes a U. A positive one goes up, a negative one goes down. If you don't remember any of that, we can make a little XY chart and plug in numbers for X and get out values for Y and plot it on the graph. The thing that is very telling of a piecewise graph is the second part here. This is the boundary line. All right, they're talking about two different lines here. First of all, how do I know they're lines? What's the exponent on both of these? First power, right? So it's a line. So they're saying they want you to graph 2x plus 3, but they only want the values that are what? Less than or equal to 1. And then they want you to graph the line negative x plus 4, and they only want the values that are what? Greater than 1. All right, piecewise can be confusing if you try to do absolutely everything in one step. If you take it in little parts, this is really easy, okay? I want you guys to follow along with me. Some of you, on your notability, this is real easy because you can erase lines and stuff. Some of you will want to bring color pencils and stuff for your quiz. You're more than welcome to. But we're going to do these piecewise functions together. Let's look at 55. This is how I think you guys should do it. All right, I'm going to use two different colors. I have two lines. I have 2x plus 3, and I have 3 minus x. So the first thing I'm going to do is I'm going to write 2x plus 3. When I have 2x plus 3, I identify for myself that the slope is what? 2. 2 over 1, good. And what is the y-intercept? At positive 3. The next thing I'm going to do for myself, just so I don't get myself confused, is I'm going to draw a quick little picture of the direction that this line goes. What is the direction of this line? It's up. It's a positive, so it should be going like that. Everybody with me? All right, now the thing that is different on this is this part. What is the boundary line that they want me to look left or right of? Where x is what? 0. So I want only, on this part of the line that I graph, I only want the values that are bigger than 0. Does everybody understand that? Mm-hmm. And then one extra thing is what kind of a dot am I going to put at the end of my line? Why? Because it's not included. Perfect. So let's not do anything else other than just graph this and figure that part out. So my y-intercept is at positive 3, right? So 1, 2, 3. And I'm going to do a dotted line because it's hard for me to erase because I'm doing explain everything. But you guys will see what I'm talking about here. So my slope is 2 over 1. So I'm going to go up 2 and here. Up 2 and over 1. Down 2 over 1. Down 2 over 1. Does everybody agree with me? So look, you can connect with a full line if you want to. I'm just going to go with the dotted.
Wait, I thought that it couldn't be less than.
Yeah, hang on one sec. You can, if you already see that, then you can do that. Jackie's saying, wait. I thought we had a boundary line. We absolutely do. What is the boundary line? 0. So I'm going to go where x is 0. Because remember, we're only talking about the x value. And remind yourself, where are the values that we want? Where x is what? Well, x is what? Not 0. Less than 0. So guys, from that boundary line, where are the x values less than 0? To the left or to the right? To the left. So I want a big open dot right here because it's not included. I want everything down here, but I don't want what? Everything to the right. So I'm going to do what? I'm just going to erase it. So I didn't want the whole line. I just wanted a piece of the line. And we always put arrows on our lines. Everybody with me? I'm going to do 59 next, and then I'll come back to 57. All right, let's do the next one. I'm going to do the exact same thing. I'm just going to pick a different color. I have 3 minus x. That makes me cringe. I'm going to write negative x plus 3. Okay, what's the slope? Negative 1 over 1. Good. What's your y-intercept? Your y-intercept's at 3. And then my line's going to go downwards, right? Okay. So I'm going to just plot those points starting at 3. And it's negative 1, so that's so easy. Down 1 over 1, down 1 over 1, down 1 over 1. Up 1 over, up 1 over, up 1 over. Okay, so now I'm going to go boom, boom, boom. Right? Everybody with me? Okay, so do I have a boundary line in this one? What is the boundary here? Greater than or what? Greater than or equal to. So what kind of a dot am I going to have here? Closed, shaded. So Jean, this kind of comes into play with what you just asked. Our first dot was open, but now this one is what? Closed. So think about it, guys. Here is my boundary line for my second line that we're talking about. It happens to be at the same place that the first one was. That's not always the case. But where on the x-axis, I'm not worried about the y, the x-axis, where are all the values greater than 0? Which way? To the right. So that means I want to color this in, and then I want all of these over here. And what do I do with the stuff that I don't want? You just delete it. On your paper, you're going to have to erase it. You guys, when you're doing this, all right, I want you guys, if you have markers or something like that, and you want to bold the pieces you want, whatever, or if you want to erase, which you have to make it apparent to me that you know what part of the line we are keeping and what part of the line we're not. Right? Remember I told you guys, if I have to guess, I'm probably going to guess wrong. So we don't want, just make sure I know what you erased and what you didn't. We okay? All right, let's look at 59. We may not get to 57 today. No big deal. All right, what do we notice about 59? There's 3. 3 what? 3 lines. How do you know they're all lines? All right, first power. Guys, what is f of x a fancy way of saying? Y. I just took for granted that you guys know that. I should remind you of that. All right, so I'm going to do 3 lines now. The first one I'm going to write is x plus 3. What is my slope? Slope is 1 over 1. What's my y-intercept? I have positive 3, and this line is going upwards, right? Because it's positive. Okay. Let's look at our boundary line. Where's my boundary line for this first equation? Or expression, I should say. Greater than or equal to, so that means I have what kind of a dot? Closed. All right, good. So let's graph it. Here, can I change this and just do it right below it? It's easier. So it's at 3, right? Slope was 1. Up and over, up and over, up and over. So I'm going to connect my dots. My boundary line for this first one is at 0. So I look at my graph and I say, okay, I want all of this stuff on the x-axis that is less than or equal to 0. So look at your boundary line that I drew. To the left or the right, where are all of the values less than or equal to 0? To the left. So I'm going to have a big closed dot right there because it's or equal to. And then I'm keeping everything over here. That's the first piece of the line that I want. And what do I do with the other stuff? I'm going to erase them and get rid of it. And these are piecewise because you just want a piece. All right, smarties. This is the easiest line to graph, and this is the one that's going to knock our socks off. This says y equals 3. What kind of a line is y equals 3?
Horizontal.
Great. It's a horizontal line at what? At 3, at y equals 3. So look, it's a horizontal line right here. Remember, y equals are horizontal lines. It's where the graph goes through. Okay, perfect. So now let's make another boundary line. Where are my boundary lines here? Between what and what?
0 and 2.
Perfect. It's between where x is 0 and where x is 2. All right. What kind of a dot do I have on the 0 boundary? Open. What kind of dot do I have at the 2 boundary? Good. Make sure on your quiz I can tell which dot is open, which is closed. So now we look at this, right? Again, this question comes up like Jean just asked us. There's already a closed dot there. So now do I open it up? No. Closed supersedes open. So I only want values from here to here. I just want this piece in the middle. Does everybody see that? Just that piece between 0 and 2. So then what do I do with everything else? We're going to erase it. We always look on the x-axis. I only want the values that are between the intervals of x equals 0 and x equals 2. I just erased too much. Sorry, that's my bad. My internet's lagging a little bit. All right, then my last one. You guys are doing great. My last is 2x minus 1. So 2x minus 1. What's my slope? 2 over 1. And what's my y-intercept? -1. And what kind of a dot do I have? Open. All right, if there's already a closed one there, then it doesn't matter. So my y-intercept is at -1, which is right there. My slope is +2. So up 2 over 1, up 2 over 1, up 2 over 1. Do you guys see how each one of these graphs have overlapped? It does not always happen. For teaching purposes on these, it's nice that it did, but it doesn't always happen. All right, and what's my boundary line on this one? Where x is what? X is 2. Okay, so we'll go right here to 2. Now I look and I say, okay, from that vertical boundary line, where are all the values greater than 2? Greater than or equal to? Which way? All the ones on the right. There's already a closed dot there, so I want to keep all that good stuff. And then what do I do with all the other nonsense? We're going to get rid of it. Now, if you tried to do all of this without writing things down, without talking yourself through each line, this is very confusing. But if you treat each piece of your piecewise separately, graph it, then look, okay, I want this stuff to the left. I want this stuff to the right. This is not as difficult as it may appear. Does that make sense? Questions? All right.